Hey guys, I thought we'd have some Newtonian fun for this video. I'd also like to mention that I originally wanted to only use logic nodes for this, but I couldn't find sufficient nodes, for example, to directly access the mass for these objects. Let's start by looking at Newton's gravity formula. So as you can see, it says force equals the gravitational constant times mass 1 times mass 2 divided by radial distance squared. Okay, let's go ahead and start writing our script. I'm just going to call this gravity, import BGE module from mathutils import vector for vector math. Then we're going to get the controller, I'll just keep it short. BGE.logic.get current controller. We're also going to need the ohm, which is self equals cont.owner. Also going to have scene equals bg.logic.get current scene. Okay, let's go ahead and get access to these two objects in the scene. We're going to make two variables, one called mass1 and another called mass2, equals scene dot objects, and then the object that you want, which would be mass1, and mass2. Same thing, just going to copy and paste this and change one thing, call this moon. We're going to make a variable called direction equals mass1 dot world position minus mass2 dot world position. We're going to make another variable called r, which will be inside of our gravity formula. Direction dot length. So we're going to get the length between mass 1 world position and mass 2 world position. We're going to make another variable, which is the gravitational constant, which I believe is 6.674. And now we can go ahead and type out our gravity formula. Force equals, and we're going to go ahead and put these in parentheses to make sure everything is in the right order, even though I believe the computer will handle it automatically. G times mass 1, and we have to put dot mass to make sure it's actually getting access to the mass of that object, times mass 2 dot mass divided by, and again we're going to put this in parentheses, radial distance squared. So let's go ahead and apply a force to this, and it should work. Ohm.apply force direction dot normalized. We're going to go ahead and normalize this. This is going to normalize the vector length to 1 to make sure it's consistent length times force. So let's go ahead and apply the script to both of these objects. First, I'm going to apply it to Earth. and then we could apply it to the moon as well. And let's see what happens. As you can see, it sort of works. The moon is kind of doing what it's supposed to be doing. However, the Earth is moving away from the moon. That's because we are going to need 2 different scripts for this and switch up mass 1 and put it in the place of mass 2 and mass 2 in the place of mass 1. Due to this gravity script being inefficient, as in it requires 2 separate gravity scripts, it also presents another problem, and that is we can only use 2 objects. And what if we want to use more objects or planets? We could do that. So let's go ahead and remove these 2 lines of code. And let's go ahead and do a for loop for mass 2 in scene.objects. And let's do an if statement. So now we're going to say if mass 2 is not equal to ohm. So, for example, if according to the Earth, and it has the script applied to it, this is considered ohm. This is considered mass 2. The moon is considered mass 2 to Earth, and vice versa. If mass 2 is not equal to ohm and has attribute mass 2 and mass 2 dot mass is greater than 0, then let's keep this. Let me go ahead and move this variable up here. And keep this stuff here. Let's move that real quick. I'm just going to copy this. And we also have another problem, and that's we don't want the objects to overlap. So let's fix that by saying if r is greater than 0.1, what is happening? If r is greater than 0.1, we're going to put that logic in here. And go over this real quick. We're going to change this one to mass 2 and this one to ohm. And this one to ohm, and this one to mass, keep that one as mass 2. Okay, let's try and see if it works. So it does seem to be working fine. And basically this part behaves as an inverse square law. For example, the further away, let's say the moon gets away from Earth, the gravity gets weaker. The closer it gets stronger. Let's go ahead and see that. And you can read this. So now we should be able to also have more planets or objects or whatever. I'll be back. Alright, as you can see, I added some more planets. And let's see how it looks. I hope you guys enjoyed this video. If you did, please leave a like. And please subscribe to my brother's channel, Ruthless Radical. And my sister's channel, Bubba Brownie Ireland. I believe that's what it was called. Anyway, yep.